Okay, morning Year 10. Hopefully yesterday went well. I have to say, extremely impressed with the work that you're doing at the moment. Really, really good quality stuff. Just to reiterate again, please do upload your work to the correct page. So what I've done is I'm going to create a new page each lesson. For today's lesson, please do upload it into the 24th of April, area of similar shapes continued. So at the end of the lesson, a lot of you are getting really, really quick at this. If you are struggling to do this, please let me know or speak to someone else in the class. I know Anna's done it really well, so if you're in contact with Anna, she'll be able to help you. But that's been really good. Right, okay, let's go straight in to the lesson today, and we're doing area of similar shapes continued. I'm going to disappear now. Have a great weekend, guys, and I'll see you again next week. Okay, area of similar shapes continued, and these are sort of harder examples, I'm going to say. So I'm going to go straight in with EG1, and this is working backwards in some extent. So working backwards. Right, now it says cone A and cone B are similar. Okay, they're similar. The surface area of A is 98, and what I'm going to do is I'm going to put that on here, 98 meters squared, and the surface area of B is 288 centimeters squared. Sorry, they're both centimeters, not meters. Centimeters squared. Okay. Calculate the height of B, which is labelled H. Now, to get from A to B in terms of area, so the area scale factor is going to be times 288 over 98. Now, if I do that on my calculator, I should get it's quite a horrible number, so I'm just going to leave it. I'm going to leave it as a fraction. Now, that does mean, though, that the length scale factor is going to be the square root of the area scale factor. So remember, the area scale factor was the length scale factor squared. Well, to get from lengths, you just have to square root that. And if I follow the arrows now, it's 28, because that's my must equal. So H must equal 28 times the length scale factor, which was the square root of 288 over 98. Okay, and if I do that, what you'll find is actually quite a nice answer, which is good. It's actually 48 centimeters. Okay, so that's how you do that. Most people just times it by the area scale factor, but you are better than that. Remember to square root it because you're talking about lengths, not areas. Right, example 2. Again, this question, a very similar question to this, came up in the GCSE paper last summer. It's one that really tricked a lot of people, so just be aware of this. Now it says hollow cylinders A and B are similar and made from metal. 69% more metal is used to make cylinder B than cylinder A. Now this is a little bit tricky because you're not certain if this is volume or area. I'm going to assume it's talking about area. Okay, it should. So assume area is 69% more. Now that is a little bit of an assumption. It should make it more clearer in the question. So surface area is 69% more. Calculate the diameter of D. Right, if it's 69% more, I'm going to just allocate numbers here which make it easier for me to deal with, and 100 is usually a sensible one. So I'm going to call this one 100. Let's say let that be 100 millimeters squared. And that means B would be 169 millimeters squared. Okay, because it's 69% more. It's really irrelevant what numbers you choose. I'm just picking 100 because it's really easy to deal with. Okay, so hundreds are usually a good one to start from. Now to get from here to here, because I'm going that way, I times by the area scale factor again is times by 100 over 169, because it's 100 over 169 there. Therefore, the length scale factor would be times by the square root of 100 over 169. Now you might want a bit of surds practice. You can square root the top, square root the bottom. That's the same as 10 over 13. Once I've got that, the question's actually quite straightforward because D is equal to 16.9 times 10 over 13, which is which is in itself 13 millimeters. So you don't have to, if this is 13 millimeters. So it's not a big increase, is it, in diameter, but the surface area would increase quite a lot, 69% more, in fact. Right, that's a sort of slight advancement on what we did yesterday. Your classwork today is Hegarty. Okay, it's Hegarty work. I've set you 2 tasks, and that will be due on Tuesday. Okay, due on Tuesday. All right, good luck, guys, and have a great weekend, and I'll speak to you next week.